Hey, welcome. Good afternoon. Still. Let me see. Hey, man. Okay, welcome to the FEAR Meetup of our community. Today I will be talking about BAN. That is a new runtime that is getting some noise, some traction. I really been excited about that. I really like JavaScript on the server. Bond is I have not been this excited since 2011. That was when I discovered Node, and before that was when I discovered Ajax in 2005. That was only one article in the internet talking about Ajax, and that was like, for me, was like, what, this is something that will have a future. I joined into the Ajax boat. I jumped into the Node boats when I discovered, and now I'm jumping into the bomb boats too. I have the same feeling, so that is because I'm investing some time and I'm talking about this. What is Bond? Bond is an all-in-one solution. It's different to Node in some aspects. Like in Node, we have just the runtime and nothing else. If we want to install package, we need to choose npm, pnpm, yarn, or whatever new that come, but we don't have a package manager. If we want tests, we need to choose Jest, Mocha, Ava, whatever we want, but we need to choose. If we want a bundler, I think every month or every time, like count a new bundler, so we need to choose Webpack. Don't choose Webpack, but Webpack. It's build, I don't know, byte, whatever, but we need to choose. The same, like we need to choose a lot of things because Node only give us a runtime, a good one, but there are nothing else. But Bond have everything for us. Give us the runtime, give us the package manager, give us the bundler, and give us the test runner. So we don't have to choose. Everything is integrated, and is behind a just executable called bomb, and that is all. So what key feature can we have with BOM? BOM is focused in performance. That is something that I was kind of sad before BOM because I was looking, going or falling behind in performance. For example, in my company, we use mostly Go because Go have a good performance. I don't like the language, but I have to acknowledge that it's very good in performance. There are better options if you want performance, but it's very good. Give us the runtime, give us a package manager like test runner, a bundler, package runner, and this is important, TypeScript is a first-class citizen. We don't need a compiler for TypeScript. We don't need like a lot of tools, but that we need to work with TypeScript in Node. That we need the compiler. If we are working in development, we need TS Node to compile the code when we are developing. To don't do that manually. So it's another tool. We are just adding and adding dependencies. TypeScript, BOM don't need that. BOM have like an integration with TypeScript, so compile the code for us. So it's not a fight, but Node, BOM disappear the necessity, or we don't need all these tools, SBill, RxPath, partial rollout, Webpack, TSC, Babel, PNPN, NPN, Yarn, Bytex, all these tools that I mentioned before, we don't need them because BOM have that integrated and is very fast. So what the impact of BOM in performance? Like, is have a lot of the APIs of Node and web APIs natively implemented. Node have a lot of native modules are implemented in JavaScript, not in C++, that is the language that Node core is built. So a lot of APIs, Node APIs, are inherently slow because they are built on JavaScript. Everything in BOM is natively implemented, so it's faster. There are obsession with performance. Jared, that is the main of the creator of BOM and the main developer, have an obsession with performance, and this is because he created BOM, because he was very unsatisfied with no performance. Another reason is because use JavaScript core and not V8. That is the engine that a Node use. JavaScript core have a very good performance. In a lot of tasks, V8 have like the winning some others, but JavaScript core like generally have like a very good performance. And another option is implemented using SIG. That is a kind of new language that is provide a fine-tuned option to increase the performance of our solutions. So BOM is intended to be a drop-up replacement for Node, but right now it's not 100% pair-to-pair with Node. So this is like a table of how is right now. So fully implemented this is a comparison between Node API and BOM, the BOM implementation of this API. So fully implemented, there are 30 APIs, partially implemented 15, and not implemented 5. But the team is working in this very, very hard. They are, for example, Jared and the whole BOM team asked to any person that have like a problem with their package, don't create that issue in the package or in the library. Create an issue in our repo because we want to solve that. So they are taking responsibility of any broken compatibility. So if I found like a issue in, I don't know, Lodash running on BOM, he said, don't create an issue in Lodash, create an issue in our repo in BOM, so we will fix that. And also for companies. If your company is having a problem with BOM in performance, in something that is not working, there are like an email specific for that. So you can just send an email with the describing your issue, describing the problem, and they will work immediately on that. Because the team obsession with performance is not just in the running, in the runtime execution time, is in how the team works. So how we can start to use BOM is it's kind of easy, except if you are using Windows. Right now, there are just a very alpha version for Windows, so it's just available for Mac, OS, Linux, or WSL. In WSL, that is Windows Subsystem for Linux, work perfectly. So if you are on Windows, just use WSL. Otherwise, this command works for any Unix, Linux system. And if you want to install a specific version, because right now there are like 4 versions, if we want to say, after the version 1, there are 1.0.0, 1.0.1, 1.0.2, 1.0.3, and 1.0.4. So if you want a specific version, you can specify the version for the command. Somebody create a VM, like a BOM version manager if you want it, but I think it's not necessary right now, but exists. So the presentation is short. I want to go to the code time that is more interesting than listening to me talking about. So I have some code that I want to present. I have some synthetic benchmark, and I have also like an API that I implement using Fastify, Prisma, and Postgres SQL. That is kind of like a common set of tools for REST APIs. So let me start my Docker. Because the database is running on Docker. Okay, it's not starting. Why? Let me see where I am. Okay. This is not working, but it's okay. It's running, yeah. And it's supposed to be working, so let's use Postman. The code is the same for any, it's a Fastify API, and it's not using nothing special from BOM except the performance that have like provide to Fastify. It's a simple API. I have some routes for posts, profiles, and users. This is just a Fastify API. And I'm using Prisma to access the database, like is the ORM. And let's see, I have user here. Should work. It's not working. Let me change. Why it's not working? Okay, it's because I need to start the server. Sorry. Oh. I have, yeah. Born, run, start. See. Where I am. Okay. I update the code and forget it. Okay. Sorry. Let me change. Okay. Now this is connecting the Fastify API through Docker, running in Postgres, and I get in the data just with, it's running with BOM through Fastify. So we can just start to use BOM to run our normal APIs. For example, Express run is the BOM team tests BOM against the most common libraries. For example, Express, Fastify, and I don't remember all, but a lot of common. And I test with Express and I test with Fastify. Yeah, Fastify. I like Fastify because it's have a very good performance. So this is just an API in Fastify running on BOM. So it's nothing stop us to start to using BOM right now. So this is a code that I want to show running BOM for just API. I have some other, come on. I have a series of benchmarks that I want to show. Requests. This is just a code that I make a request to this waiter API. So we can run it with, I have here Deno, I have Node.js, and I have BOM, last version of each one. And let's do this benchmark. For example, I'm using Hyperfine. So let's go to benchmarks. Requests. So I will run the code with the three tools, with Node.js, with BOM, and with Deno. And this tool will run each one. And in the end, will give us who win, if we want to say it like that, and how much time take. So it will take some time. I have some tables, some graph that, for example, I even test with Go. That is, let's see this graph here. Where I have it? Yeah, it's this graph. Is visible for everybody, or do you want to increase? Okay. So this is, while the other benchmark end, this is a test that I've run using the HTTP server for each tool, no libraries. For example, the HTTP module of Node, BOM, Deno, and Go. Deno have like a lead, but not for a lot compared to BOM. Deno is coming to place, and Node come like really behind. This is something that I'm getting very happy to see, like that BOM is closing this gap between Go, because it can give us the option to say like, hey, Go have a better performance, we know, but the time to market with BOM, with JavaScript is way shorter. So if not every API, for example, that we want to build need that performance. Like performance is always nice, but sometimes it's not necessary. It's overkill. We are not getting this amount of requests right now, so it's an early optimization. And for example, if a startup, we need time to market, a really short time to market. So we are not dealing with this amount of requests, so we can go with the second option, that is BOM, and have like a very short time to market. Let's see if the test ends. I have it here. Why is failing in the presentation? Sorry. Huh? No, fuck. Sorry. Use the. Let's run another one. Yes, that normally happen. So let's go for the computing. That is intensive tasks, CPU tasks. Like, for example, a common one is Fibonacci. Like the Fibonacci calculation of 40. I already have it here. The same. Something is happening with the request. I don't know if my API key it's not working. We start to see some so Deno is the closest always to bomb, but in this task that is Fibonacci calculation of the number 40, we can see here the mean is like between the maximum and the minimum for Node.js. That is the first one is this number. For bomb is this number, and for Deno is this number. So you can see that it's kind of half of the time for Node, and I don't know, like 60% of something like that, or more than, or less than Deno, like 70% of the execution time that Deno take for a very, like for intensive calculation. Another one that I have that is even more intensive is the Monte Carlo P approximation. This is an algorithm that can calculate the P, the P number using a mathematical formula. It's approximation and it's very intensive. And I already have it in Go, so we can compare. Okay. This is the algorithm. I'm using 1,000 million of points. That's literally what is doing this is calculating numbers in a circle, and with this he can create calculate the approximation of P. And it's a lot of points. So it's taking some time because it's very intensive, but you can see the result. In the end, I have the same algorithms in Go. It's the same except it's in Go. We can run it in the end. Well, I can add it here. But this is anything. Let's open the question if you have some question. I want to see by yourself the benchmark result, but we can start to a conversation. Daria have a face of have a question.
The question is, here is very artificial text.
Yeah.
You run some math calculation, but in reality, you want maybe run a ghost block platform. Where is it fast? Does it run in fast or only in Node.js?
Like all the tests that, yeah, all the tests that this is called like, yeah, it's our test, synthetic test. Yeah, like it's not a real life scenario, but all the algorithms are the same, running the same machine, so can give you like a baseline to compare the tools. Like in all the tests except one, Bone always win, or Deno. Like just in one run, Deno comes first for a little margin, but if I run several times that benchmark, I say 90% of the time Bone win, and Deno always is close. But compared to Node, the difference is a lot. Like, for example, in that test that we see that is double, or Deno take half of the time, Bond take half of the time for intensive CPU calculation. And when we are dealing with requests, it's also, the difference is big, like compared to Node, with basic Node.
But this is calculation, this is math.
Yeah, this is just math, mathematics. That for me is even more impressive because it's something that always when you was dealing with this, always people is like JavaScript sucks for this type of task. But Bone is start to close this gap with other language, like with compiled language like Rust, Go. Is not still losing, but it's losing for less. And I have in the end a good news about this specific topic. So in the end, I have like after that slide, there are another slide. Sorry. So, but yeah, like if you need very intensive CPU calculation, you need a better solution. You go for Rust, for example, or Go. But Bone is closing this gap.
And you're talking about real applications next.
For real application, yeah, like for example, the first one that I show, like the REST API, that is a real scenario. Like it's just running Fastify without changing anything. I just install Bomb, install Fastify, Prisma. Like I install the package with the Bomb package manager and just start to coding and just work. So I don't have to change anything for this API. And I have this, I post something in LinkedIn and somebody asked, I post like the result on LinkedIn of this calculation and somebody asked me if I run in Python this, I did it and I regret it. Yeah, Python. I answered him like Python and performance can be in the same sentence. Like Python is amazing, but if you need performance, Python is one of the last options because literally it's interpreted, not like JavaScript that is compiled. It run in a runtime, but it's compiled. So yeah, and. No, different. Like in Deno, it's TypeScript. They also have like TypeScript is field class citizen, but they don't have a bundle. For example, they use sbuild. This is built in Rust that is very performant, but it's external. It's external to the runtime. So there are overhead in that transpilation. So the Bomb team just put everything inside so the communication is way faster. And they don't have this obsession with performance. I will show here. Oh, this is taking a lot forever. Like even Mateo Colina, that is the Node creator, acknowledged that. Yeah, Fastify, and is one of, sorry, it's not the creator of Node, it's the creator of Fastify, and is one of the main developer right now, or contributor to Node.js. When I put it here, and why? Because this guy, Jared Sumner, that is, wait, I hope pronounce it well, he have like this type of obsession with optimization, with micro-optimization in memory, in how you allocate the pointers in the language to reduce the memory consumption, to make the pointer calculation faster. And this is something that even Mateo acknowledge that this is that the team have like goal. Like if we can do a micro optimization, we will do it. So this is the big goal for the BOM team, is always being focused on performance. And that is something that the Node team don't have, not because they are lazy, not because they are dumb, it's because they have other goals. And also they have a legacy of, I don't know, from 2009 that they have to maintain and don't broke the whole ecosystem. So it's harder for the Node team focus on performance even if they want, but BOM team start from scratch. So with this goal from scratch is easier, and also with our session is easier too. This task is not finishing. Fuck. Okay, I have the graph here. Fortunately, I run it in home and I have the Monte Carlo. So. Oh, I thought I have the Monte Carlo. Look like no. Okay, but I have other ones. For example, this is a Node and BOM running Fastify. So Fastify is a project right now that is built for Node. They are not using BOM server. That is way faster than Node that we can see in this graph. But even running Node server in BOM is faster. This graph is not well done. At the time for Fibonacci, you can see here like a graph, like similar to the one run that I make before. This time JSON is, we can see the code, but basically is populating like a big object with different type of properties, booleans, numbers, functions. I run this and measure the code. And also a good thing is BOM introduce a different way to work with files. Like BOM file. For example, I want the data of a file. I just say BOM file, the name of the file, .test, because I can get the data. This give me like a buffer, so I can get just the test, or I can get the binary data, but it's just like this. And you don't have to import any package, it's right there. If I want to write, it's similar, BOM write, file name, data. So it's simple, easier than you have to import the function that you want to use. After that, use it. Yeah, if you want the promise, you need to invoke fs promise. Yeah, it's more cumbersome. Deno is also more terse. You can say like just write test file or read test file. And let's see how it's a server in BOM that is also way more terse. Like if you want to write a basic server with BOM, is BOM ser, the port, and this is the request, and you can respond. The same in Node is a little bit more of code. You need to import the create server. You need to descend, pass the port. This is a very simple server. Deno is also very terse, similar to BOM. I have, yeah, I compare Express, I compare Fastify. It's the same code. And I have the graphic here. And I want to show you the, let's say, version of Monte Carlo in Go. Monte Carlo. Oh, I need to time this. It's running the same amount of point, with the same amount of point. With that is because I increment the amount of points from the last time. That is because it's taking more time. My benchmark than before. This is using 1,000 million of points and executing 31 seconds. So let's run, let's stay the same number. And let's go back and open the Monte Carlo PJSON. And let's paste this the same. And time, bomb, Monte Carlo. And let's compare with the Go to see how much is Go win. But if we do the same in Node, we'll take like almost double that bomb. So that is the question that you need really a lot of performance. Still, bomb is not the performance in CPU calculations.
So it comes with an equal test method, right?
Yes.
But if I want to use something else, can I point it to
Use it? Yeah.
And because my worry is that long term, if you disagree with some design choices, you're kind of stuck with runtime, the package manager, testing.
It's not a prison. You can, BOM gives you the tools, but you can use JS and run JS. Yeah, no problem. You can install with NPM, yeah, but with BOM, would take way less time and way less space because why the package manager in BOM is really fast because they are not copying the file. When you install a package and you already have it in cache, what other package manager do, they create a copy. And that's because your computer start to, your free space start to decrease. But what is doing the BOM team? They are creating hard links from the cache package to your node module. So your node module don't have a copy of the package, have like a hard link to the cache. And in Linux, that is very performance. In Mac, the hard link is not as performant, so they don't do the hard link solution. They are using the clone file API of Mac OS that is not as good like hard link in Linux because Mac OS is not an operating system for development. So, but it's very performant. So, yeah. And in Windows, they are creating a version, but still is in development is very green. But they promise to release like a pair Windows version.
I don't think Windows is operating system for
No, that's I use Linux for my. This is a Windows, but I'm using Linux like for my development environment because yeah. And why I'm using this because dealing sometime in Linux when I was 100% and I have clients with VPNs that have not official client and I need to spend a lot of time configuring the VPNs because companies don't give you support if you use Linux. So I say, okay, I use Windows for install the VPNs and everything run on Ubuntu in WSL. More questions? Yeah. Still is small because the version 1 was released this month. The development have more than 1 year, but the official version 1 was released, I think, 2 weeks ago or a week and a half. So I think it's the same like Node when Node started in 2009. Like people was watching this type of meetup in 2009. Somebody just talking about Node and nobody Node, sorry, was the same concern. And now we have with Node in this. So BOM is not trying to replace Node, and that is the best thing that I see, and is pushing, I think it will be push Node and Deno to the performance path. But right now, yeah, I don't have like a graphic of market share. And it's too early to search for that graphic because it will be a small. But there are. Yeah.
But what kind of entities have literally grabbed it that you know but they will actually like it? Are they in a specific sector or are they just
There are some companies that are offering BOM support, like SaaS, like computing provider, like I already implemented BOM support. I don't have it right now in my mind, but I read it and I can provide you. If you give me an email or something, I can send you a list of the companies that already have like official BOM support. That you don't have to just, they are like an official Docker image in Docker Hub if you want to try it, but there are some companies that already have, in cloud computing, already have official BOM support. So it's getting traction. More questions? Like JavaScript core is not one thing.
Yeah, but when you do this math, code
Yeah, like because it's not just one thing that say, okay, they replace V8 with JavaScript core. That is one thing. The other thing is the language. C is very good for performance and for fine-tuning. The tier one, yeah, but the tier one is the obsession with performance. Like, you can use a language like, let's see Ross, you and me, and we can write, like we have received a user story, and we produce in the end the same result, but one of the binaries can run faster just because you or me implement a different optimization. And that is the same. Like these guys have like this in mind, like go for the extra mile for performance. That the other teams was more focused in compatibility, or Deno is focused on, Deno take another path, like take the path of TypeScript. That yes, that Node is implementing now. Exactly. It's providing a lot of things that even Node is having now. The permission thing, like model, is very nice. But it's several things together that come to this result. It's not just the drop replacement on JavaScript core, or not just a new language, or not just the obsession. Is everything together. And also, they are implementing things differently. Like, for example, for some API that I mentioned, like if you go to the code base of Node in GitHub, you can see a lot of modules that in JavaScript. This module never will be as performant like native, even if I write that I am not like the best developer on the world, but even if I write that module on ROS will be performant. We have a better performance than in JavaScript. And more questions?
Maybe a philosophical question. How to think about fun? So is it a new tool which looks like JavaScript, but you need to run application specific for fun to use all the benefits? Or may I just bring my existing JavaScript application, run it with fun, and benefit from run CPU and faster performance and blah, blah, blah? What's
Yeah,
the problem?
that is because I bring the API example, because I'm touching nothing from
From
the,
API,
yeah.
but may I just bring my JavaScript of Node.js application,
Mhm.
and there is a goal that it should run much
Yeah.
faster.
Exactly.
And if it doesn't, what should I do?
You can do it like like, because I execute the same code, like for example for the P or for the Monte Carlo, it's the same code. It's not, there are not API here, it's just calculations. So if you execute this code with BOM, you have like a better performance. But there are some APIs that if you are reading files and you use the read file from BOM, if you will have even more performance, because the read file in the BOM API is execute faster. The BOM server execute faster. So if you bring your code and you touch nothing, you have like a better performance. Not a lot, but you have a better performance. But if you start to modify, for example, with an API, and you use like a library that is built for BOM, for example, that under the hood use BOM server, you will have like even more performance. If you change your file access from FX to BOM file system, like in the system management, you will have better performance. So you start from the start touching nothing, you have like a better performance. But if you start to refactor, and you can start little by little, because it's not something that it's not running, but you just start to running with BOM, and if you are using a server, you can, and for example, use a different library that mostly all the libraries use the same API, like Fastify, Express, Restify, look kind of the same. Like you maybe can touch a little bit and that works. So the refactor for dropping a different API library is small. So you can start refactoring little by little, and you will have in the end having a way more performance.
If you write specific or fun, it is faster.
Yeah.
But you can run general application. I tried to prepare for this. I told fun. Okay, nice. I have a super cool. I can run it. I run CDK. You know CDK? It's a tool for Amazon integration, and it just died.
Yeah, because not like, do you remember that a table where not all the APIs of Node are totally implemented? So there are some packages that are broken right now, and do you remember when I say that if you have a problem with this package, don't create an issue in the package, because it's not the issue, it's our issue because we are not able to run this package.
I should just wait.
Yeah, if it's not working, just wait.
Okay.
Yeah, because the goal of them is have 100% compatibility, but they start with the most common modules, like server, file system, like the thing that we use the most. But there are some ones that, like the performance hoods, they are not 100% implemented. It's in the partial implementation. So with time, they will implement all the APIs.
Do you need help with like maybe register a ticket, provide a test case when it's not working, a simple test case when it's broken? Do they need this or?
Yeah, for example, in the web page, you can, if you know what APIs are you using, in the BOM side, there are like very detailed lists. Node.js compatibility. So you can see here that is like Node Asser is full implement, async hook is not implement totally, and there like cluster is not implement. They are basically nobody is using cluster now, so they just ignore cluster by from the beginning. Crypto, Crypto is not totally implement because Bone include a native crypto module. So you can use the crypto module of BOM. So you can see here what diagram, I don't know if you are using, but for some reason, this package that you're using probably is using something from here of that is not implemented or partially implemented. Yeah. And something that this is the next excitement that I have recently is after my last, oh, come on. Okay. Come on. Yeah, I don't pray to my gods. Do you listen about the static Hermes before? Okay. This is my hope. This is a project very new. It's not ready for production. It's completely green, but it's from Facebook. Do you know React Native? Yeah. The runtime of React Native is called Hermes. And what is static Hermes? Static Hermes is C performance with JavaScript usability. What that means, that it's not a runtime. It's literally compiling JavaScript code to native code. But what we need for that, we need some types. So what is the problem with languages that don't have types? That you can create really performant native code because you don't know the types beforehand. But static Hermes require and for you is optional, but if you want really performance, you can use type. It's thin in TypeScript, but with a better type checking, like because types in TypeScript are unsounded. So you can broke the type system in TypeScript, but with some types, it's kind of coding in Rust or coding in Go is really enforcing the types. The static Hermes compiler, because it's a compiler, will take your JavaScript code with types and create a binary that you execute. So that will give us really the performance that we have from Go, from C, from Rust, but with type. Let's call it TypeScript if we want, with JavaScript with types. And that is because I put this background, because it's like this history of JavaScript is progressing really fast. This is the last step that I was praying to my God to come, because this is like what we was needing to compete with Rust or Go, that right now BOM is closing the gap, but it's not there. But the static Hermes is what will give us this amount of success with JavaScript. And I can't tell too much about static Hermes because literally don't have even a repository. It's a branch in the Hermes repository, because they are just working on that. In the presentation they show the compile code, but yeah, it's not available yet. Okay? Maybe in the future I will be talking about static Hermes, but not now. More questions, or we can close and go for talking together and eating pizza? Are you in the Slack channel? Are you in the Meetup group? We have both, so start and there, like we share news and tools. Okay. Thank you. And if you have a suggestion about tools or want to give a talk, this is open. Just come. And if you want some suggestion for talk, we can talk about and create a talk for that together, or you or me, or yeah, let's go. Hmm?
The demo log, they need real beer, says Maria, that's why it doesn't work.
No, because in the end,